Hello guys, today we're going to go over 4.2, which is an excellent section. It's pretty much experiments. Now note, most of my background as far as experiments and surveys and data gathering, data collection analysis goes is based on my medical career. But just note that this applies to pretty much everything. Economics, publicity, just random data collection and surveys. But I got a lot of background on medical experiments, and it's very common in the medical field, of course. Now, first of all, we're going to go over the observational study. As its name states, observational study just observes individuals and measures variables of interest, but does not attempt to influence their responses. Now, there's something very important. Does not attempt to influence the responses. So you try to take a hands-off approach. But keep in mind that there's something called the Hawthorne effect, which stipulates that people behave differently just because they know someone's watching them. A very famous experiment was done a couple of years ago, and they just put they were gonna, just to test Hawthorne effect, they actually put, and this was kind of unethical, we'll see why later when we get into the ethics of data. But they just randomly recorded people washing their hands to see how many people actually washed their hands after using the restroom. And then they had a study to see how many people washed their hands, and they put somebody to watch the sinks where people wash their hands, and pretty much everybody washed their hands when they were being watched. So the fact that people know they're being watched will change their possible behavior. You have to keep that into effect. And again, it's tricky because you also can't record them without them knowing, but there's certain ways to get around that. We'll get into that a little bit later. So that's pretty much observational study. Next, response variable and explanatory variable. We went over that a couple of sections ago, but let's review the definitions. Pretty much a response variable measures the outcome of a study. If I want to see how much weight people are losing based on a certain diet or exercise plan or pill, that's pretty much the response variable. Weight loss. If I want to see how much more athletes can sustain a rhythm running or something, I know how much more time spent maintaining that rhythm would be the response variable. It's what you're trying to measure. And an explanatory variable may help explain or predict changes in that response variable. For example, having a low-fat diet, weight loss considerable, and the explanatory as well. If you have a low-fat diet, you have a tougher time finding calories, and you have to burn off your own fat, etc., etc. So response variable is a variable you're trying to change or manipulate using explanatory variables. All right. Confounding. Confounding pretty much means that when two variables are associated in such a way that their effects on a response variable cannot be distinguished from each other, they are called confounding variables. So let's say, for example, sex and height determines a certain activity. I don't know. Again, I'm trying to be diverse and inclusive. But let's say like two variables, you can't tell apart which one's actually causing the effect because they both do at a more or less the same amount. So there's no way to tell them apart. That's pretty much confounding variable. And you can find many of them in many different studies. An experiment. An experiment deliberately imposes some treatment on individuals to measure their responses. Now remember, studies is like an umbrella concept. Studies, there's a whole bunch of studies, cohort studies, a cross-sectional, control, observational studies, cohort, case control studies, and there's also experiments. But in the experiments, you actually try to influence the response variable by putting something into that environment. Exercise, food, more people, less people, you name it. And you're trying to see whether that thing that you're introducing has a change in the response variable. That's the whole point of the experiment. And it's one of the pillars of the scientific method. And we're gonna get into replication a little bit later. Now, placebo is incredibly important. A placebo is a treatment that has no active ingredient, but otherwise it's pretty much identical to other treatments. This is important because we'll see later. You've heard the phrase mind over matter, that people can think themselves into feeling differently. Well, that's actually true in many cases. So when you have a study and people don't know whether they're getting the treatment or a placebo, they're just going to try to respond normally instead of, oh, I didn't get anything. I feel horrible. Yeah, I feel worse than yesterday. I'm dying. Please give me treatment. So again, the placebo is incredibly important to try to get rid of that mind influencing a person's behavior or actions. It's actually quite interesting. And it has many real world effects. For example, well, I'll go over that in class. Don't want to talk about this particular event that happened in med school, but I'll go over it later. It's quite interesting. Now let's go over treatment, experimental units, and subjects. A specific condition applied to individuals in an experiment is called a treatment. Now note, treatment, you think, oh my God, yeah, I'm gonna feel better, yay. Bueno, sometimes treatment might not be a positive thing for the individual, even though, or might not be a clearly positive thing. Like maybe let's have this individual eat a high-fat diet. We know that's not the best thing, but it's still called treatment in the scope of the experiment. So treatment isn't always good, but you'll see later the ethics involved in these experiments are very interesting, incredibly interesting. But yeah, just know that treatment isn't necessarily always a good thing. But you don't want to expose your subjects to bad things, but sometimes it has to happen. Like a scary picture, to increase their blood pressure, or extreme exercise regimen, something like that. You'll see, it's quite interesting. If an experiment has several explanatory variables, a treatment is a combination of specific values of these variables. An experimental unit is the object to which a treatment is randomly assigned. An experimental unit, for example, it could be a lab rat. It could be a particular car. You're putting a new fuel inside that car. It could be a human. So an experimental unit is the unit to which that treatment is applied. And subjects are pretty much the population of your experiment. Normally they're human beings, but everything could be termed a subject. So that's pretty much it. But we usually reserve those for human beings or other animals. Factor and levels. Now, in an experiment, a factor is a variable that is manipulated and may cause a change in the response variable. Let's go back to the whole losing weight as my response variable. A factor could be no exercise, 15 minutes of light exercise, 1 hour of very difficult and strenuous exercise. These are all factors, and they manipulate the explanatory variable weight loss. The different values of a factor are called levels. So for example, in exercise regimen, I could have no exercise, 15 minutes light exercise, 1 hour medium exercise, 2 hours of strenuous exercise. Those would be the levels of the factor exercise regimen. And you can have as many factors and as many levels as you need to try to influence the explanatory variable. But note, due to confounding issues and a whole bunch of cost, time, data analysis, it's very difficult to add a whole ton of explanatory variables. You try to really pinpoint and try to maintain your focus because it gets very difficult. I'm not sure who said it. It was, I think, a Roman Greek philosopher, can't remember. He was one of the fathers of experimental observational studies. He said, the difficult part isn't asking the questions. The difficult part is understanding the answers. Okay, I asked this question, I got this answer. I got so many answers. How do I reach the truth? Or, the closest thing to the truth, and it's very difficult. So the more variables you add to try to explain the explanatory variable, it's going to be rather difficult to see what exactly did what. So that's something to keep in mind. Control group, and this has evolved a lot. The control group is pretty much like a baseline group in which a placebo or no treatment is given, just to see how the treatment influences a group that is exposed to that treatment. Now, in some cases, there's no problem. Like, let's say, for example, let's show these people some pictures. We'll show a person a picture of, cute little fuzzy bears. We'll show another a picture of sharks, venomous snakes, spiders, and a whole bunch of scary animals. And let's have the control group just sit in front of a TV and just have it turned off. Yeah, no big deal. They got bored. They lost 15 minutes of their time. Really, there was nothing negative that happened in these people in this control group. But when we're talking about treatment and possibly life-saving treatment, being in that control group might mean that you're not receiving treatment. So again, at least in medicine, many ethical advances have happened, like crossover control groups, that at some point you're not taking the actual medicine, they are recording results, and that at least at some point of the study you do get the actual treatment. So it's quite interesting. There was an excellent movie called the Dallas Buyers Club. Came out 5 years ago, 10 years ago, I don't know, won Oscars, Matthew McConaughey. It goes a lot through the whole medical approving, ethics, control, and treatment group. And in that movie, I remember people were fighting to get into that treatment group because at the moment, that was the only treatment they had for that particular disease. We're probably gonna do a project about that movie, actually. Sounds good. So pretty much the control group is just a group that is not exposed to treatment, to keep like a baseline measurement of what happens in the absence of, and just manipulating the explanatory variable, or with the absence of an explanatory variable. Okay, placebo effect. Again, we went over it. I kind of talked about it, mind over matter. The placebo effect describes the fact that some subjects in an experiment will respond favorably to any treatment, even an inactive treatment. That happened to one of my patients. I'm going to go ahead and just talk about it. There was this patient who came in complaining about a stomach ache, and I was going to treat this person, and another doctor who knew this patient said that this patient had a mental disorder, and they complained about pain just to get that treatment because they were pretty much addicted to the treatment drug. And he said, just take some water, rub it on the patient's belly, tell them it's that exact same substance you're giving them, and you'll see how they react. And effectively, I just told the patient, yeah, you're getting this treatment. And no, this happened before we confirmed that there was actually anything wrong with the patient. Okay, again, it's not ethical to just give placebos to people who might be in trouble. But in this case, the patient went from, just really screaming and hurtful and agony. I just rubbed the water on the stomach, and then they just went to perfectly normal, goodbye, thank you for everything, doctor, walked out the door. That's the placebo effect in action. Okay, just people who think they're getting what they need just behave differently, regardless of whether something's happening or not. Double blind, single blind, there's even triple blind, but the book goes over double and single. Single blind is pretty much the people who don't know, the people who are subject to the treatment, or the people interacting with those people who ask the questions and such, don't know whether they are in the control or treatment group. And the double blind is also, let me go over the definition here. Double blind, neither the subjects nor those who interact with them and measure their responses know which treatment group they're in. Yeah, okay, in single, either the people in the groups don't know whether the control treatment or the people who interact with them. Double blind is the people, and also the people in the groups, and also the people who interact with them don't know what they're doing. And some certain cases are triple blind, which is the people who actually do the mathematical analyses don't know which group is which. That's assigned to a third-party company to provide the results. It's actually quite interesting. And again, this is all done to try to reduce bias. Because again, if you invest millions and millions and millions of dollars trying to see whether this pill is going to make some people lose weight, you want it to make people lose weight. And that might have a certain influence on people's behaviors. So again, the blind studies are really important to at least try to avoid certain biases. Again, remember, biases can never be eliminated, only reduced. Random assignments. Pretty much people are assigned randomly to certain groups. There was a time when people could choose, no, you assign them randomly. You don't get to choose who gets exposed to a treatment or a control. If you have a candy bar, you're not going to choose all kids to join the candy bar group and all the adults to join the broccoli group. No, you assign them randomly and people respond randomly. Again, trying to reduce bias. Give me 1 second. Sorry, my screen jumped. Okay, almost here. I do apologize. I hate working on my iPad for that exact same reason. Okay, almost here. Okay, we went over random assignment. Now we're gonna go over control. Control just means keeping the other variables constant for all experimental units. And keeping all the values constant, in some cases it's not a problem. Like let's say you're in a very controlled lab environment and you're trying to see how a certain level of moisture affects the plants growing within that environment. That's easy to control. When you're talking about, people working out in an outdoors park where it might rain, other people might bump into them, things might happen, injuries. It's not that easy to keep everything under control. But again, it is your job as a researcher to try to control as many things as you can, okay, and plan to control that. Replication, incredibly important for the scientific method. Again, the basis of a lot of our knowledge. In an experiment, replication means using enough experimental units to distinguish a difference in the effects of treatments from chance variation due to the random assignment. Again, if I can replicate the same result with a particular treatment in multiple experimental units, that means that the treatment is probably having an effect on these. And we're gonna go over that a little bit later. Let's say, for example, the whole water moisture thing. I wanna set the water moisture to 20% for my treatment group and 5% for all other groups. And most, if not all, the treatment group who had that 20% growth, the plant grew twice as much. I replicated that growth about twice as much in many experimental units. That's replication. Replicate the results. And not only the results, also replicate the entire study if need be. So it's quite interesting. Replication is incredibly important. If you can't replicate anything, you have nothing. Literally. Oh yeah, I discovered this thing that happened this once and nobody else can replicate it. Good luck getting that published in a proper scientific journal. Not gonna happen. Completely randomized design. Again, a completely randomized design, pretty much the experimental units are assigned to the treatments completely by chance. And this means that you can have different treatments. Okay, so they're assigned randomly. Again, it's probably the best way to do it. Block, randomized block design. Let's go over definition. A block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to treatments. Let's say, for example, weight loss again. You have a group of athletes, which is a block, and a group of random, school teachers. And let's see who can lose weight faster. It's probably gonna be the athletes because they're used to exercise regimens, diets, etc., etc. So an experimental block are people who have similar characteristics that might in themselves cause a different response given the treatment. Okay. A randomized block design, the random assignment of experimental units to treatment is carried out separately within each block. So that means that, let's say, for example, the whole scary picture and fuzzy picture experiment. You have a group that's going to have scary pictures and a group that's going to have fuzzy, nice pictures. And you're just going to randomly assign people into those two blocks. That's randomized block design. Pretty important. Matched pair designs. The matched pair is a common experimental design for comparing two treatments that use block sizes of 2. You can have multiple size of different blocks. Athletes, school teachers, children, and this other block to see how people lose weight. But matched pair is specifically blocks of size 2 blocks. In some matched pair designs, two very similar experimental units are paired and two treatments are randomly assigned to within each pair. In the others, each experimental unit receives both treatments in a random order. So for example, I am matched to this other person in the other study. He might get again, we're talking about experimental units from different blocks. He might get treatment, I might get placebo, and then at some point it might flip, etc., etc. That's how it works. And they're gonna compare, matched pair. And that's why you can only have 2 blocks. Now that's it for 4.2. 4.3 is very, very short, so we're gonna go over it in the exact same exercise. And it's quite interesting, and that's what our project is going to be based on. Now, let's go over the first definition in 4.3, which is sampling variability. Sampling variability refers to the fact that different random samples of the same size from the same population produce different estimates. If I'm going to sample 10 SMS students, well, if it's 10 students, I'm going to get a way different response, or not way different. I'm going to get different responses based on just randomly selecting students. I might get, 5 first graders in the first random sample. In the next sample, I might get no first graders and, 9 eighth graders, for example. So taking different samples from the same population will lead to different results. That's sampling variability. You have to understand that. And probably the most important definition from this video is this last one: statistically significant. And when the observed results of a study are too unusual to be explained by chance alone, the results are called statistically significant. Now, in statistics, that's called P, the p-value. Normally, it's 0.5. We're going to get into that because that's actually very interesting. Because you can manipulate the p-value, and changing the p-value will change the chances of a type 1 error or type 2 error happening. And we're also going to talk about the basics rules of the game, but I'm going to talk about that in a particular video just for that, because it's extremely interesting. So I'm not sure if they're going to focus that in this book, but we are definitely going to talk about it. And incredibly important, it's not a definition, but it's in the big green boxes. Let's go over it real quick. The scope of inference. It says random selection of individuals allows inference about the population from which the individuals were chosen. And inference is taking a conclusion from a smaller population and applying it to a larger population. If I pick 3 cars and all 3 cars were horribly damaged and they didn't work, and I took that from a particular seller, I can probably draw the conclusion, even though it might be incorrect. Maybe I just got very unlucky from that sample, but I can say that probably many other cars within that seller are damaged or not properly working. And the other scope of inference, random assignment of individuals to groups, allows inference about cause and effect. That one's a little complicated. Basic data ethics, incredibly important. Let's go over this. And again, the project is actually going to be very interesting. I think we're going to have a lot of fun. All planned studies must be reviewed in advance by institutional review board charged with protecting the safety and well-being of the subjects. If they're, even if the people aren't put in danger, usually the experiment has to be reviewed. This review board is put up, it's not just like a whole bunch of scientists choosing, it's actually normal people. You got priests, policemen, office workers, random people from the street. So you got many different people from many different backgrounds who can try to vouch for the safety of the people in the that are going to go through that particular experiment. That's incredibly important. Sometimes these experiments do not go through review boards, problems happen. Next, all individuals who are subjects in a study must give their informed consent before data are collected. Not consent. Consent is just yes. Informed consent, understanding what's happening. You can't just go to a random foreign country, have people sign a document, and then do whatever you want because they signed the document. Informed consent means that not only are they understanding, but also that you're not taking advantage of a high-risk population, like the elderly, children, people under your power. In doctors, it could be patients or students if you're a teacher, etc., etc. Also, prisoners are a high-risk population or vulnerable population, and the poor. You really have to try to avoid, when possible, to try to include these people in your study unless it's absolutely necessary for the study, because these are vulnerable communities. You don't want to, you want to try to not take advantage of them. Okay, and we can go over how each community is taken advantage of. Many people say, "Oh, prisoners, yeah, no, you can't take advantage of prisoners. You can't, even though some people would love to. You can't. Vulnerable population, we have to be ethical." And the last one, all individual data, not all data, all individual data must be kept confidential. Only statistical summaries for groups of subjects may be made public. Again, if you can't publish any data, why the heck are you doing an experiment or a study? The whole point is to keep the individual safe and draw conclusions from the sample population. That's pretty much it. We're gonna go over in class about, I might do a video, type 1, type 2 error, statistically significance, what that actually means. It's quite interesting. It's, I think, one of the most important classes you'll take this year. So take care, I'll see you soon.